Okay, now let us discuss exercise 1.4. Find the union of each of the following pairs of sets. So we have set x is equal to 1, 3, 5 and set y is 1, 2, 3. So union of sets means you collect all the elements in both the sets. So x union y is 1, 2, 3, 5. Let us write in order. If possible, it's a material, you can write in any order. You first write down all the elements of set x, then comma you write elements of set y, no problem. We have to collect all the elements, that's union. So here 1, 2, 3, 5 is the union of x and y, that is x union y. And second question, a is a, e, I, o, u. So a, e, I, o, u, the vowels, a set of vowels. Then b set is the set b is a, b, c. So a union b means you write down all the elements of a, then elements of b. So when you put in order, it is a, b, c, e, I, o, u. But if an element occurs in both the sets, it's enough you write only once, no need to write 2 times. And set question number 3, x is a natural number and multiple of 3. B, x is a natural number less than 6. So write in roster form. So a is multiples of 3 means 3, 6, 9, etc. It's a natural number as well as multiples of 3. And b is a natural number less than 6. So 1, 2 until 5. That's b. So a union b means, so until 5 you can write 1, 2, 3, 5. After that it's only the second set, set a, 3, 6, 9, etc. So if 3 already there, you already written already, so no need to write 3 once again. So 6, 9, 12, etc. And question number 4, x is a natural number and 1 less than x less than or equal to 6. B, x is a natural number and 6 less than x less than 10. So putting in roster form, a is the natural number and x 1 less than x less than or equal to 6 means 1 is not included where 6 is included. Therefore it starts from a is 2, 3, 4, 5 and 6. 1 is not included. So natural numbers from 2 until 6. Then set b is natural number and 6 less than x less than 10. So 6 and 10 are not included, they are open interval, not included. Therefore it starts from 7 and ends at 9. So set b is 7, 8, 9. Therefore a union b is, you write down all the elements of a and the elements of b put together, you get 2, 3, 4, 5, 6. Then elements of b 7, 8, 9. And for fifth question, a is 1, 2, 3. Set b is empty. So a union b is just 1, 2, 3 because b is empty, no elements. And question number 2, set a is a, b. Set b is a, b, c. Is a is a subset of b? And what is a union b? These are the questions. And when you see that element a, set a has elements a, b, and set b has elements a, b, c. So all the elements of a are in set b. Therefore a is a subset of b. So the first question, yes, it is true, a is a subset of b. And a union b is a, b, c. Collecting all the elements of a and b, you get a, b, c. And question number 3, if a and b are 2 sets such that a is a subset of b, then what is a union b? Okay, now if you can consider the previous example, you look at that a union b is a, b, c, that's nothing but b. So if a is a subset of b, then a union b is the set b. So we can apply that here. So a is a subset of b given, therefore a union b is b, because all the elements of a is already in b since it's subset. Therefore you write all the set of elements of b, that is nothing but a union b. And question number 3, given that A is 1, 2, 3, 4, B is 3, 4, 5, 6, C is 5, 6, 7, 8, and D is the set D has elements 7, 8, 9, 10. Now we have to find the following sets. So A union B, you take elements of A and B put together, you get 1, 2, 3, 4, and this B has again 3, 4, no need to write once again, so 5, 6 extra elements, so put it there. So you get A union B. And A union C, write down the set of elements of A, 1, 2, 3, 4, and then elements of C, that is 5, 6, 7, 8, because no element is repeating here. So you just combine both the sets, you get A union C. And B union C, B is 3, 4, 5, 6, till that it's B, and C is again 5, 6, so no need to write once again, and 7, 8, the last two numbers, elements. And B union D is, you write the elements of B, 3, 4, 5, 6, and D is 7, 8, 9, 10, so that is B union D. And A union B union C, so you can take A union B, and with that you can add C. So A union B already we have seen here, 1, 2, 3, 4, 5, 6, and with that add C. C is 5, 6, 7, 8, so 5 and 6 already are 10, no need to write once again, so 7 and 8. So this is A union B union C. And A union B union D, so you can take A union B union D. So B union D already we have seen in question number 4. So that is 3, 4, 5, 6, 7, 8, 9, 10. And in that add 1. So 1, 2, 3, 4. 3 and 4 already there. So no need to write twice. So write just to start from 1 and 2. So 1 and 2, then 3, 4, 5, 6, 7, 8, 9, 10. That is A union B union D. And question number 7. B union C union D is B union C union D. So you write B union C. B union C is 3, 4, 5, 6, 7, 8. So write 3, 4, 5, 6, 7, 8. Then D is 7, 8, 9, 10. Already you have written 7, 8. Don't need to write once again. So extra numbers are 9 and 10. So write put 9 and 10. So you had B union C union D. Then question number 5. Find the intersection of each pair of sets of questions 1 above. So question number 1, you write down the sets once again. The question, there is x is 1, 3, 5, and y is 1, 2, 3. So there we have seen union of sets. Now we have to find the intersection of sets. Intersection means the elements common to both sets. Here x and y. So you take the common elements and put it in a set that is intersection of two sets. So 1 is a common element because it occurs in both the sets, and 3 is another common element. Therefore x intersection y is 1, 3. And A intersection B, second question, A, E, I, O, U is the first set A, B, C is the second set B. So the common elements are only A. So A is here, A is here. So no other element is common in both the sets. Therefore A intersection B is a singleton set A. A is third question, x is a natural number and multiple of 3. B, x is a natural number less than 6. So putting in roster form, the set of elements of A are 3, 6, 9, etc. and set B are 1, 2, 3, 4, 5. Therefore A intersection B is the only element common in both the sets is number 3. So just 3. A intersection B is 3. And question number 4. And x is a natural number and 1 less than x less than or equal to 6. So in putting in roster form, the set of elements of A are 2, 3, 4, 5, 6. And the B is set of is x such that x is a natural number and 6 less than x less than 10. Therefore, the set of elements in B are set B is 7, 8, 9. Now we observe that no element is common here. Therefore, it's an empty set. or you write just two ways to write empty set. Either you put two double bracket without any letter, or you just put the letter cross it 5. So A intersection B is an empty set. And question number 5. A is set of elements 1, 2, 3. B is an empty set. So A intersection B is empty. If any one set is empty, the intersection is empty, because B has no element. Therefore, the common element is empty. And question number 6. Set A has 3, 5, 7, 9, 11. And set B has elements 7, 9, 11 and 13. And C has 11, 13, 15. And D has elements 15 and 17. So we have to find the following: A intersection B. A intersection B means common elements. We consider the sets A and B. Now the common elements are 7, 9 and 11. Here also 7, 9, 11 is there. So the A intersection B is 7, 9 and 11. B intersection C. So we can write B intersection C. You look at that, the common elements are 7 is not there in C, 9 is not there in C, 11 is there, 13 is there. So we can take 11 and 13, that is B intersection C. And A intersection C intersection D, you take one by one. First you combine A intersection C, then you take intersection with D. So A intersection C is only 11 is the only common element. So 11 intersection the set containing element 11 is then another set D is 15, 17. So no element in common, therefore the intersection is empty. And A intersection C, just now we have seen it is the 11. And B intersection D, so we have to consider B intersection D. B is 7, 9, 11, 13. D is 15, 17. No element in common. Therefore, it's an empty set. B is the empty set. And A intersection B union C. So set A is 3, 5, 7, 9, 11. And B union C. You can just combine B and C. You get 7, 9, 11, 13, 15. So 7, 9, 11, 13, 15. Now we have to find the intersection of these two sets. So the common elements are 7, 9 and 11. So A intersection B union C is 7, 9, 11. And A intersection D. So A intersection D. A is 3, 5, 7, 9, 11. D is 15, 17. So no element in common. Therefore it's a null set. So A intersection D is a null set, or an empty set, or a void set. You can call that as in three ways: null set, empty set, void set. And the last one, question number 8, A intersection B union D. So A is nothing but 3, 5, 7, 9, 11. B union D is 7, 9, 11, 13, 15, 17. So intersection of these two sets is 7, 9 and 11. So that completes the answer for this question. And question number 9. Okay, A intersection B intersection union C. So A intersection B is 7, 9 and 11. A intersection B. And B union C is 7, 9, 11, 13 and 15. 7, 9, 11, 13 and 15. Now intersection of these two sets, A intersection B union C, is once again it is 7, 9 and 11. So then question number 10, the last question. A union D intersection B union C. A union D is, you can look at the sets. A union D is 3, 5, 7, 9, 11 and 15 and 17. So 3, 5, 7, 9, 11, 15 and 17 is A union D. And B union C is 7, 9, 11, 13 plus 11, 13, 15. That gives 7, 9, 11, 13 and 15. Now we need to find the intersection of these two sets. So there are 7 is there in both elements, 9 is there in both the sets, 11 is there and 15 is there. So these are the common elements. Therefore A union D intersection B union C is 7, 9, 11, 15. Question number 7. Set A is set of all x such that x is a natural number. B is set of all x such that x is an even natural number. And set C is set of all x such that x is an odd natural number. And D is set of all x's such that x is a prime number. So find A intersection B. These are the subdivisions. We have to find out all this. Now let us put in roster form. Set A is set of all natural numbers. So 1, 2, 3, 4, etc. That is A. And B is x is an even natural number. So that is 2, 4, 6, 8, etc. And C is odd natural number, that is 1, 3, 5, 7, etc. And D is a prime number. So even prime number is 2, 3 is a odd, then rest of all odd prime numbers. So 3, 5, 7, 11, 13, etc. So now A intersection B. So you can say that B is a common elements 2, 4, 6, 8. So you can say that A intersection B is B. And A intersection C is a set of all odd natural numbers. So you can observe that from these two sets you see that 1, 3, 5, 7 are the common elements. Therefore that is odd natural numbers. And A intersection D is, you can say 2, 3, then after that only set elements in D, that is 5, 7, 11, 13. So 2, 3, 5, 7, 11, 13, etc. And B intersection C. B is even natural numbers, C is odd natural numbers. Obviously nothing, no element in common, therefore empty set. B intersection C is an empty set. And B intersection D is only 2. When you see that B has 2, 4, 6, 8 and D has 2, 3, 5, 7. So 2 is the only even prime number. So when you compare B and D, the common element is only T. It's a singleton set. And C intersection D. So C is 1, 3, 5, 7. D is 2, 3, 5, 7. So you get 3, 5, 7, 11, 13, 17, all the prime numbers. So 19, etc. Because all prime except 2 all are odd numbers, and C is all odd natural numbers. So part of it is odd prime numbers. So you get this set, and it extends, it goes. And question number 8. Which of the following pairs of sets are disjoint? Disjoint means A intersection B is empty. There is no element in common. Then if two sets have no element in common, then we call that as disjoint sets. So set A, first question is 1, 2, 3, 4 and 2. Second set is x is a natural number and 4 less than or equal to x less than or equal to 6. Okay, first question. We have to check whether this is disjoint set or not. The first set is 1, 2, 3, 4. Second set is natural number lying between 4 and 6. Both 4 and 6 are included. So 4, 5, 6. So the only common element, there is a common element. 4 is a common element. Therefore, these two sets are not disjoint. They have a common element. And second question, A, E, I, O, U, first set. Second set, C, D, E, F. Obviously, E is a common element. It's the letter E is there in both the sets. So this also not disjoint. And third question is x is an even integer, x is an odd integer. So even integer, it can be positive or a negative integer. So plus or minus 2, plus or minus 4, plus or minus 6. And odd integer is plus or minus 1, plus or minus 3, plus or minus 5, etc. So there is no element in common. Therefore, these sets are disjoint sets. And question number 9. If A has elements 3, 6, 9, 12, 15, 18, 21 are the multiples of 6 are 3, then set B is 4, 8, 12, 4, 16, 20. It's the multiples of 4, 8, 12, 16, 20. And C is 2, 4, 6, 8, 10, 12, 14, 16. It's an even number or multiples of 2. And D is multiples of 5, 5, 10, 15, 20. And we have to find the difference of sets, the given set. So 1 A minus B. A minus B means the elements in A but not in B. So we have to collect all the elements of A which are not in B. So B has 4, 6, 12, 15, 16 and 20. So 4 is not there in A, 8 is not there, 12 is there. So we can cut 12. That's all. So 12 is the only element which is in B. Therefore you write the remaining elements of A, there you get A minus B. So 3, 6, 9, 15, 18 and 21. And A minus C means all the elements of A excluding the elements of C. So you get 3, 6 is in C, so you can cut 6. And 12 of course. That's all. So A minus C, the remaining elements 3, 9, 15, 18, 21. And A minus D, same way. You got only 15 is not there. So you can write 3, 9, 6, 9, 3, 6, 9, 12, 18 and 21. That is A minus D. Then B minus A. Now B minus A means set of elements in B which are not in A. Now we have to consider set B. So 4, 8, 12, 16, 20. So 12 is in A, so cancel that. So the remaining elements are 4, 8, 16, 20 and C minus A. So you have to subtract elements of A from C, write remaining elements. Of course 6 is in A, can cancel that. And 12 is in A, that's all. So remaining elements are 2, 4, 8, 10, 14 and 16. That is C minus A. And D minus A, same way. You collect all the elements of D minus A. So that is only 15 is common in A, so cancel that. So 5, 10 and 20. 5, 10 and 20. Then B minus C. B minus C. Of course here also 16. 8 is there in C. And 4 is also in C. So only element is 20. So B minus C is 20. And B minus D. B minus D. So what are the elements in D? So only 20 is there in D. Other elements are not in D. Therefore B minus D is 4, 8, 12, 16. B minus D is 4, 8, 12, 16. And C minus B. Set of all elements of C minus B. So C minus B is C minus B. 4 is in B, 8 is in B, 12 is in B, 16 is in B. So C minus B is remaining elements 2, 6, 10 and 14. C minus B is 2, 6, 10 and 14. And same way D minus B. D minus B is only 20. So 20 can cancel that because 20 is there in B. So 5, 10 and 15. So you get D minus B is 5, 10 and 15. And C minus D. C minus D. D 10 is there in D. That's all, only one element. So no other element is in D from D. Therefore you can write C minus D is 2, 4, 6, 8, 12, 14, 16. So 2, 4, 6, 8, 12, 14 and 16. So that is C minus D. Then the last one is D minus C. Set of all elements of D minus C. So the only element is the only element found in C is 10. So you can write the remaining elements 5, 15 and 20. 5, 15 and 20, that is D minus C. So this is how you find the difference of sets. Then question number 10. X is A, B, C, D, and set Y is F, B, D, G. So find X minus Y. That means set of elements of X which are not in Y. So B is in Y, can cancel that. D is in Y, therefore the remaining set of elements in A are A and C. So that is X minus Y. And Y minus X is set of elements in Y which are not in X. So B is there, cancel B, and D is in AX, so we can cancel that. So remaining elements are F and G. So F, G is Y minus X. And X intersection Y, the common elements. So the common elements are B and D. So X intersection Y is B, D. And question number 11. If R is the set of real numbers and Q is the set of rational numbers, then what is R minus Q? So set of real numbers means by broad definition it is set of rational numbers and plus irrational numbers put together is R. So you can say that therefore when you subtract rational numbers, then R minus remaining elements in R are only irrational numbers. Therefore R minus Q is set of irrational numbers. So rational numbers plus irrational numbers forms real numbers. So if you take out rational numbers, the remaining one is irrational numbers. R minus Q is set of irrational numbers. And question number 12. State whether each of the following state is true or false. Justify your answer. So 2, 3, 4, 5 and 3, 6 are disjoint sets. It's false because it's not disjoint because 3 is an element in common. For disjoint sets, no element should be in common. Therefore, it is the given sets are not disjoint. The reason is 3 is a common element. And second question, A, E, I, O, U, A, B, C, D. So once again here A is a common element, therefore it's not disjoint. And C part 2, 6, 10, 14 and 3, 7, 11, 15. So the intersection of these two sets is null set, empty, no element in common. Therefore these sets are disjoint sets. And fourth question, 2, 6, 10 and second set is 3, 7, 11. So there are no elements in common, therefore these sets are disjoint sets. So that completes this exercise.